in thinking, how could I go back and get you guys to get better prepared for the retake, I created this quiz from scratch, or not quiz, this worksheet from scratch. I made this morning. I actually just on Word, I just started typing up questions, right? So I made a section that was just on factoring quadratic trinomials that have the a value of 1. That's not the first method of factoring we learned. We learned how to pull out a GCF first, but if you look, all of these on this section have the a value of 1, right? Ax squared plus bx plus c. The a value is 1 right here, a value is 1 right there. There are none of these that have an actual number in front of the first term. They're all just x squares. So since all of these have an a value of 1, you jump right into this factored form format. Parenthesis, 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 x, x. Okay, everybody should do that right now in number 1. And the trick is, what times what is your c value, which is negative 24, that if you combine together is your b value. So I don't even think about b right now. I just want to focus in on that c value of negative 24. And I want to make a list of all the multiples of negative 24. And I start with the number 1, like 1 times negative 24, 2 times negative 12, 3 times negative 8, 4 times negative 6. And that's it, right? Besides changing signs. So always make a list. And then from there, just start adding the values on your list. Instead of multiplying, add them. Like, what is 1 plus negative 24? That's negative 23. Is that a negative 23? No, it's not. How about negative 12 and positive 2? If you add those together, what do you get?
Negative 10.
You get negative 10. That's a negative 10. This is the right pair of numbers that we want. It's that simple, guys. Yeah, this pair of numbers right here, that's what we want. And you don't want to change any signs. It works out perfectly. So we're just going to put a positive 2 and a negative 12, and you're done. That's it. Really, really easy. If you're not too sure about it, you could go ahead and distribute x times x, you get the x squared. X times negative 12, you get negative 12x. But then 2 times x, you get positive 2x, and the negative 12x and the positive 2x really does give you that middle value, negative 10x. So you could distribute to double check your answer if you're ever confused. Let's actually jump to number 5. So right here, again, because the a value is 1, because there's just an x squared right there, you could set up your factored form format, parenthesis, 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 x, x. Why is that? Because x times x is x squared. If you had a 6 right here, you couldn't say x times x, because if it were a 6, you would need something like 6x times 1x, or maybe 3x times 2x. Or, I mean, it makes it more complicated. You have to use a different method of factoring than just setting up the parentheses with your x's. And instead of just... well, in this case, there is no number, so you could think what times what is negative 28, that if you combine together is your b value. I say make a list. How could you get negative 28? Start with the number 1. 1 times negative 28. 2 times negative 14. 3 times doesn't work. 4 times negative 7. So we have those 3 possible multiplication problems that give us the negative 28 when we multiply them. Now, which one of these, when we combine them, give us the middle value 12? Well, negative 28 and 1 is negative 27. That's not a negative 27. Negative 14 plus 2, that's a negative 12. And that's a positive 12. So we do have the right number, just the wrong sign. So that means we have the right numbers, just the wrong signs. So yes, we're going to change that to a negative, change that to a positive. And that will be your factored form, minus 2 right here and a plus 14 right there. And if you're not too sure about it, you could distribute to double check it. Again, this is all about you guys practicing your skills. That's why I'm only doing a couple of them. Let's take a look at number 9. Number 9, we're going to set up parenthesis, 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 parenthesis. Why am I able to do this? Because there's no number in the front. If there were a number in the front, you wouldn't be able to do this where you have a simple x right here and an x right there. If you had an 8 right here, then it wouldn't be x times x. It might be a 4x times 2x or 8x times 1x, but then that would change everything. So we have to use a different method. Right here, there's a value of 1, so I could set this up. And then I jump to my list. What times what is 54? 1 times 54, 2 times, and if you don't know, get a calculator and go 54 divided by 2, and that'll give you 27. And then you could go 54 divided by 3 to find out what 3 times what gives you 54. Anybody have a calculator? I think it's 18. 3 times 18 is 54. But again, if you divide 54 by 3 on a calculator, it'll give you that answer 18. So you'll know it's 3 times 18. 4 times what gives us 54? It doesn't work. 5 doesn't work. 6 times 9 gives us 54. And 7 doesn't work. And 8 doesn't work. And when you get to 9, you're back to 9 times 6, which you already have there. So there's only 4 possible multiplication problems that give you 54. Which of those, when you combine them, give you the middle value 15? Obviously, it's 6 plus 9. 6 plus 9 is 15. That is 15. So you're good to go. That's a pair of numbers you want. You don't have to change any signs. That's just a plus 6 and a plus 9. So we have a lot of practice to do right here. 2, 3, 4, 6, 7, 8, 10, 11, 12. And once you do those over and over and over, you should get more comfortable with these. Now, we do have a different type of quadratic right here. It's a quadratic binomial. Oh yeah, by the way, if I were up here, we were on number 9 right now. If I were up here and I was trying to figure out which pair of numbers add to give me 15, what if this were like a, let's say we're a 10, right? If it were a 10 and you couldn't find like 8 plus 13 is not 10, or 18 plus 13 is not 10, 27 plus 2 is not 10, 6 plus 9 is not 10. If you had a 10 right here, then you would just say not factorable. And it will happen at least once on this worksheet where you're trying to figure out what times what is the last one, that if you add together is the middle one. There's going to be one question at least where you just can't do it, so you would just say not factorable, or you would say prime, okay?
Every single section?
No, I think just 1 or 2 on the whole worksheet. But right here on this one, we still have a quadratic with the a value of 1. There's no number out here in the front. So you could think of it as we've been thinking of it. I could set up parenthesis, xx. Why? Because x times x is x squared. If I had a number right here, I wouldn't be able to do this. Now what do? I think what times what is negative 36, that if I combine together is the middle value, which is nothing. So if you want to make a list, you could do that. 1 times negative 36, 2 times negative 18, and if you don't know, hit 36 divided by 2, it'll give you the 18. 3 times, that's 36 divided by 3, that's 12. 3 times negative 12 will give you negative 36. 4 times negative 9, 5 doesn't work. 6 times negative 6. Now, which pair of numbers, when you add them together, give you the middle value, which is nothing?
6 times negative 6.
6 and negative 6, right? So that's the right pair of numbers that we want, and that's what you plug in, plus 6, minus 6, and you're done. Now, we also had a method of factoring perfect square quadratic binomials, which is a difference of 2 perfect square terms. If you wanted to, you could apply the square root to the x squared, you'll get x. Apply the square root to the 36, you'll get 6. And of course, one has to be plus, one has to be minus. But you don't have to do that here. You don't have to square root. You could just think, because it's 1x squared, you could set up your parentheses with the x and the x. And then you could think, what times what is negative 36? That if you combine together is the middle value, which is nothing. And that would clearly be a positive 6 times a negative 6. When you combine those, it does eliminate the middle value. Anyway, so we could practice there. And then we have this other section. And yeah, I apologize. Once again, if for some reason you don't have a minus sign right here, like if this would have been a plus 36, then this would not be factorable. Because in order for the middle term to cancel out when you're distributing, one has to be plus, one has to be negative. And if this were a positive 36, you wouldn't be able to have different signs. It would either have to be a positive times a positive or a negative times a negative to give you a positive 36, but that means that the middle term would not cancel out. So if you do have a plus sign, then that would be a not factorable, or you could say prime, whatever you'd like. Anywho, down here, we have the next section that says completely factor. What does completely factor mean? That means to pull out the GCF, then continue to try to factor. So number 19, the very first method that we learned to factor was pulling out the GCF. Is there something in common in all 3 terms? There's a 2. So when I pull out a 2, what would be left? 2 times what gets me back to 2x squared? X squared, okay. And then how about 2 times what gets me back to negative 50x? Negative 25 with an x, right? And then 2 times what gets me back to 48? Positive 24, right? Okay, so we factored out the GCF. Now, if you look at the inside of the parentheses, you have a blue quadratic trinomial, and this one does not have a number in the front, which means that maybe you could continue factoring, put an x right here and an x right there, and also don't forget to bring down the GCF that you pulled out to start with. But what we're going to do is just focus in on this blue quadratic trinomial and think what times what is the c value of 24 that if I combine together is my b value of negative 25. And of course, make a list like always. How could you get that c value of positive 24? You could say 1 times 24, or 2 times 12, or 3 times 8 is 24. Or 4 times 6 is 24. Or 5 doesn't work, and 6 you're already back to 6 times 4. So those are all the possible ways of multiplying numbers together to give you 24. Anywho, which pair of numbers, when I combine them, if I combine these, I get 25. If I combine these, I get 14. If I combine these, I get 11. Which pair of numbers gives me the negative 25 that I need?
Negative 1, negative 24.
Yeah, the 24 and the 1 gives us 25. That's a 25, but you want it to be a negative, and 1 plus 24 is positive 25. So you have the right numbers, just the wrong signs. So change it and change it. Keep in mind that you have to change both signs. You can't just change one sign. It has to be both. Anyway, this is the pair of numbers that we want, and that's what we plug in right here, a -1 and a -24. Don't forget about that outside 2 that you originally pulled out. That's your completely factored form answer right there. Now, you're not always going to be able to continue to factor on the inside of the parentheses. Like, let's all go to number 21 here, for example. Trying to pull out the GCF first. It looks like there's a multiple of 3, multiple of 3. I hope 108 is divisible by 3. Could somebody help me out with the calculator? It is? Okay, so if I do pull out a 3, on the inside I'll have 3 times x squared is 3x squared, right? 3 times x squared, it gets me back to there. 3 times what gets me back to negative 15x?
Negative 5.
Negative 5 with an x. And 3 times what gets me back to 108?
It was like 30 something.
36? Perfect. Okay, so now I see that there's a blue quadratic trinomial with no number in the front. That means that I might be able to continue factoring, thinking what times what is my C value, that if I combine together is my B value. In this case, what times what is 36, that if I add together is negative 5. So when we think about the list of 36, 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6, those are all the possible ways of multiplying numbers together to get 36. But when you start asking yourself, which, when I combine, will give me a negative 5? Well, that gives me a 37. That doesn't work. That gives me a 20. That's not 20. That gives me a 15. That's not a 15. That gives me a 13. That's not 13. That gives me a 12. That's not 12. Right? Now, some of us might be thinking, well, wait a minute. Can't I just make this a negative 9? And then that would give me the negative 5? No, it won't work. If you change a sign, it has to be to both numbers. All right? You can't just change one sign. Okay? So right here, if you add 9 and 4, that's 13, and this is not a 13. So that's it. You're done. It does not work. You cannot continue. In other words, this is your answer right here, just pulling out the 3, and that's as far as you could go. That is a true statement that you do not know if you could continue factoring unless you try. So even if I told you, like let's say 2x to the third minus 2x minus, let's say minus 40, okay? Minus 40, okay? Minus 40, let me make this an x squared and make that an x, 40x. Okay, if you're like, oh, I could pull out an x on every single term, I mean, that's a true statement. This is not on your worksheet, by the way. But if I could pull out an x, right? Now, if you did pull out an x, what would be left? You'd have a 2x squared minus 2x minus 40. But then, if you could pull out something else, you should do it, right? So this was not the GCF because I could still pull out another multiple of 2. So I should have pulled out a 2x, and then I would have gotten a x squared minus 1x minus 20, and then I could continue factoring the inside, getting a negative 5 and a positive 4 and a 2x out here in the front. I apologize. Maybe that's throwing us off. But yeah, it's a true statement that you need to always try to continue factoring the inside of the parenthesis. So let's go back over here. Check this out. Number 24. Could I pull out something out? A GCF? 2. Bless you. And what's left over on the inside?
X squared minus 4.
X squared minus 4. And then that blue x squared minus 4, since there's no number in the front, maybe you could continue factoring, putting x right there and x right there, thinking what times what is negative 4, that if you combine together is the middle value, and there is no middle value, So that will be a positive 2 and a negative 2. And if you're totally confused, let's make a list. What times what is negative 4? Well, 1 times negative 4 or 2 times negative 2. Now, which pair of numbers, when you add them, gives you the middle value, which there is no middle value, which is nothing. Well, that would be the positive 2 and the negative 2. So you're going to put plus 2, minus 2. And don't forget about the GCF that you originally pulled out. There's your final factored form answer for number 24. Are you with me?
Yes, we are.
Okay. And of course, you're going to do that with 25 and 26 and 27. And then finally, at the bottom of our front page, we have factoring by grouping. And the instructions tell you what to do. You're going to group it. You're going to separate it into 2 groups. So let's all do the first one together. We are going to separate it 8x squared plus 2x space, big space, minus 12x y minus 3y. Now, in that first group, I put parentheses right below it. What's in common in that first group? A 2 and an x. So the thought process here is, since you pulled out the 2x times what would get you back to an 8x squared? That will be a 4x. 2 times 4 is 8, and x times x is the x squared. And then 2x times what will get you back to a 2x? Well, it's already a 2x, so put a 1 right there, because 2x times 1, positive 1, will stay 2x. Anyway, for the second one, what could you pull out of the second group? You could pull out a 3. You could pull out a 3y, but the goal is to get the same binomial left over. Yeah, so let's pull out a negative 3y. Whoops. Give me 1 second. Here we go. Negative 3y. And when you pull out that negative 3y times what gets you back to the negative 12xy? That'll be a positive 4x. And then negative 3y times what will get you back to a negative 3y? That'll be a positive 1. And then, on factoring by grouping, the next step is to do some exaggerated parentheses, pull out that common binomial. What common binomial? The 4x plus 1. Pull that out here into the front. So that's the blue common binomial, 4x plus 1, out there in the front. And what's left over on the inside? A 2x and a minus 3y. So you put the 2x there, the minus 3y over there, and that's your answer, but write it with the correct size parentheses, 4x plus 1 times 2x minus 3y. All right, so there's 2 more that you guys could practice with on factoring by grouping. And there's a backside to this, but let's not mess with the backside till tomorrow, unless you actually finish this. Right now, I want you guys to work on the remainder of this front side of this worksheet, and let's get really good at factoring quadratic trinomials, thinking what times what is 32, that if you combine together is negative 12, making that list of the multiples of 32. And also, that one's what? Prime, because it's not a difference of 2 squares. Anyways, I think the video is already too long. I apologize. Let's work on this first side. On the back side, we'll go over that tomorrow, and the solutions are provided on Google Classroom.